Guess what? This is the last set of notes that we have to take this year. I hope you're really excited. This is hopefully going to be kind of short, just like the other one we had last night about static electricity. So buckle down, get ready. Last set of notes, and then we're going to start reviewing for the end of the year. I'm really excited, and I'm glad that we've made it this far, and we're going to have a good time for the last few weeks together. So let's start off just talking about magnetism and what that means. It is the attraction of one magnet for another object. And just in terms of parts of a magnet, I know we've dealt with them before, whether we're playing with the things on the refrigerator or we've had them in class before, but on a magnet, the poles are the area of the magnet where the effect is the strongest. So basically, that's where you can feel the force of the magnet the most. We've talked before about charges with atoms, and we said that opposite charges attract each other, so positive and negative want to be together, so they pull toward each other. The same concept applies here. The opposite poles, north and south pole, attract each other. Like poles repel each other, that means they push away from each other. So this picture at the bottom demonstrates this. If I have a big bar magnet and I break it in half, I don't end up with one portion of the magnet that's just a north pole and another portion of the magnet that's just a south pole. What happens is when I cut this in half, suddenly it becomes two separate magnets with a new north and south pole. So let's just assume this side was north and this side was south originally. Once they've been broken up, the opposite end automatically becomes south, and the opposite end of this automatically becomes north. So a magnetic field is the region of magnetic force around the magnet. First of all, it's invisible. If you've ever played with Magnedoodle, you can think of the little iron filings that you can kind of guide around with this pen that has metallic magnet inside of it. And you can kind of see the direction that these filings go as you move the pen along the screen. I think I have one here at school, and I'm going to try to look for it so I can show you what I'm talking about if you've never seen it before. One cool thing is that this field allows magnets to interact with each other without touching. So you may have used strong magnets before that if you put them close together but not quite letting them touch, if you let go of one, it almost jumps over to the other magnet because the attraction is so strong. So in the book, when you're back here in class, it would be a good idea to look at page 638. In fact, on our lab that we do, you're going to have a question that comes from this page. So you might want to write this down in your notes. An electromagnet is a strong magnet that has the ability to be turned on and off. And the fact that we can turn it off means that it works temporarily. Okay, it's not permanent, and an electromagnet is used to make motors and generators work. This is also how our lock works at the front door of the school. If you've ever been outside and you have to push the button to call Miss White and she has to put a little code into the phone, what's happening is that there's an electromagnet that's holding the lock shut. And when she puts the code in, it turns the magnet off for a second and unlocks the door, so she doesn't actually have to get up and come and manually unlock the door, which is pretty cool. So this is what's going to be the setup for tomorrow's lab. A very simple electromagnet is basically a current-carrying coil. It's kind of hard to say really fast. And it has many loops, and it can create a magnetic field that you can turn on and off based on if the wires are all connected to the battery or to the power source. Some examples of objects that use electromagnets include alarm bells, audio and videotapes. If any of you have an audio cassette tape or a video cassette tape in your home, or if you've seen one before, you've noticed that it's got this brown tape material, and it looks very similar to what you see on the back of a credit card or on the inside of the old computer floppy disks. They basically all use the same material in order to digitally record information onto those tapes using electromagnets and the control that you have in being able to turn them on and off. So that's why you don't want to get credit cards near magnets, or if you were to rub a magnet across the cassette or videotape strip, it would actually erase the information on there. So I'm putting these page numbers here as a reference because there are lots of pictures in the book that I did not include in this set of notes because it would take up more time, and I don't want to make this video longer than it needs to be because of different data that people have on their phones and everything. I don't want to waste time. So write this down. On page 678, there are some good pictures and examples of motors. Basically, the idea behind a motor is that it is a current carrying wire that we place in a magnetic field. And so we have a horseshoe magnet here at the bottom of this picture. And we've kind of set an electromagnet into that invisible field where the north and south are kind of interacting together. What this does is it converts the electrical energy from that electromagnet, and it starts to spin this nail that's on the inside. So this is mechanical energy. So just think about a motor that runs a car. It takes that electricity from inside the battery system and it converts it into mechanical energy for the car to run. So the loop of the current carrying wire begins to spin continuously. So that means it just spins and spins and spins without a stop or a pause. And the way that we have this continuous spin is that the current reverses within that current carrying wire. So that means the current flow is constantly going back and forth in order to get the spin to keep going all the way around. Examples of things that use motors include fans, cars, you can think about a lawnmower, basically anything that you have to kind of turn on, it has a spinning fan part. Generators have the opposite effect, and these are described more, and you have more illustrations on page 684. This is a conductor, so an object that can conduct electricity, and it's moved across a magnetic field. Some object is manually moving this back and forth within a magnetic field, and this creates an electric current within the conductor. So basics of this means that this converts that mechanical energy, the motion, into electrical energy. So there are two different types of currents that take place within the conductor. The first type is called an AC generator. It means alternating current, and alternating means that it's going back and forth. It's reversing constantly. So charges move back and forth within the wire when that wire is moved up and down in the magnetic field repeatedly. So because it's moving up and down, it's reversing direction constantly, the current itself within the conductor moves back and forth too. So this creates motion. So if you have a power outage, then generators can give you the power that you need for the electricity. DC is direct current. This is when charges flow in only one direction. And I can make a pop music reference, but I won't because I'm above that. All right, and so some examples of things that use these different types of generators. AC generators are the home generators we just discussed, and these are what's going to give you power if there's an outage. DC generators are batteries, so the electricity is always going to flow out one end of the battery and always go back into the opposite end. Natural generators, the things we use in nature to give us electricity, include windmills, tides, hydroelectricity, so by building a dam we can harness potential energy from the water. Indirectly, we can use coal, oil, and natural gas. We've talked about how nuclear power is an alternative source of energy, and we can also harness the sun's energy through solar panels. If you have any questions, this is the last time, make sure you write them down and ask them in class tomorrow, and get ready. We have a lab tomorrow, we've got review day coming up, and then we have our last test before we start reviewing for the SOLs. I hope you're just as excited as I am.